Hello friends, this is Durga again from Technology Mentor / ITversity. As of now, we are talking about building enterprise data warehouse using Hadoop ecosystem. We started with creating databases for our enterprise data warehouse as well as ODS, and we have created tables simulating this data model in ODS, and also we have created a fact and dimension table in EW, and then we have seen how we can use Scoop or Hive to integrate data from relational databases or file system into Hive based databases, and then we started looking into SQL or HiveQL, Hive query language, in which we have seen several features theoretically, and also try to understand the subtle differences of some of the features like order by, sort by, etc. And then we have seen user defined functions. Now we will try to connect all the dots and try to query data from this data model, which is in ODS in Hive, and try to load into EW, which contains the tables that are fine tuned for our reporting requirements. So this is the source data model which we have been using in MySQL database, and then we have several Hive databases. One of them is retail underscore stage to stage the data from different sources, and retail underscore ODS for operational data store, and the data model is almost the same. Only thing is, if you go to retail ODS and if you do if you run show tables command, you have categories, customers, departments, order items, orders, and products, same as our source data model. But there are a few differences, like when it comes to orders table, it is partitioned by order month and order items. Even though the order items in MySQL database does not have order item order date, we have added that column into this order items table, and then we joined data from orders and order items in a stage database to copy it into ODS. So order items in ODS also have order date and also order month, so that we can partition the data. And then we already loaded the data as part of demonstrating the insert feature in Hive. Now, using the similar data model in ODS, we will try to populate our other database, which is built for enterprise data warehouse, and you can switch to retail underscore EDW, and you can see that. So these are the two tables which have created. One is order fact and the other one is products dimension. And if you look at the structure of the order fact, it has almost all the fields from order item, order ID, order date, product ID, quantity, subtotal, product price, and also product category department. The reason I have created this table is that we actually store data mapping between department and orders, so that we can run department level metrics on the order data. Okay, so let's talk about a simple use case wherein on daily basis an executive want to see which department is getting most of the orders from this data set. So if you go to the source data, you have 6 tables, and orders have order ID and order date. So we need for each date, so we need orders table, so that we know what all order IDs are transacted on each day. So we need to join orders with order items, so that we actually see what all order items are there in each of the order, and order items have a field called product ID, and we want to have at department level which department is getting most of the orders, and department is here, which is the master table for categories, and categories is the master table for products, and products is the master table for order items. and also orders is a master table for order items. So there is a many to many relationship between orders and products, because one order can have many products and one product can be part of many orders. So the many to many relationship is achieved in transactional database using this bridge table called order items. Now to get to get the details at department level, you need to join departments with categories and categories with products and products with order items, but order items does not have the order date, so you might have to join with orders also. If you want to get the department level statistics of how each department is performing, then you have to join these 5 tables to get those metrics. And you can run this query on the OLTP database also. For example, I am going to MySQL database. MySQL -u retail underscore DBA -p. Hadoop is the password. And then I want to see department name, comma, order date, comma, sum of order item subtotal. Okay, and then we want to see from orders or join order items OI on O dot order ID equal to OI dot order item order ID. Similarly, I have to join order items with products, and then categories, and then department, and then join on departments D on C dot category department ID equal to D dot department ID order by order date, and then 3 DSC. Okay, there is no database selected, so use retail underscore DB. Okay, I need to use the group by clause. So here it should be group by department name, comma, order date. Now you can see the results. It have written 2176 rows. There are 7 departments, so for each day you got the details. So 6 departments. So fan shop is the top performing department for July 24th, and here data set is not very high, so it came back pretty quickly. But if the data volume is big, if you have thousands and millions of records, millions of thousands of records in orders or order items table, this is a pretty expensive join, and running against OLTP database can be counterproductive, and it can cause contention on your source database. For that reason, we have to build the data warehouse, do the ETL, fine tune your tables, matching your reporting requirements using dimensional modeling, and then use perform ETL using Hadoop if you are using Hadoop, and copy that data back to the reporting database and report out of it, which will render your reports much quicker compared to running against OLTP databases like this. So we are trying to simulate this requirement in our enterprise data house building on top of Hadoop ecosystem. For that, we want to pre-join this data and dump into the table, and this join is required only once per day or once per week or once per month, depending upon depending upon the interval you want to build this data set in as part of your report table or fact table. It need not be real time. You don't need to update your data warehouse in real time to develop the data model matching your reporting requirement, because for an executive it does not matter how a given transaction on a given day is performing. That is not the requirement here. He just want to see the trend of how the departments are performing within the enterprise over a period of time. For that reason, you don't need to have real-time data to support the reports. So you can actually do the batch processing of your dataset, reprocess all the dataset that matches this query requirement, and dump into a table and report against it. That being said, now you have the reporting table. You can also run the similar query in Hive also. So we have tables similar to that. We will try to copy the same query first and see if it runs. I pasted it here and it failed, saying that I think the database is not right. So let me use retail_ODS, which is the database which have the table structure similar to our source database, and now I am pasting the query. It is running without any errors. Let's see how it goes. There is something wrong here. If you see, it has thrown a warning using constant number 3 in order by. If you try to use position alias, when Hive group by order by position alias is false, the position alias will be ignored. So it did not sort in the manner we are looking for, because as it says, it is ignored. So let me go back and set that parameter. It took around 15 seconds using Tez. Let me change the execution engine to MR. First let me set this one to true. Set equal to true, and also set hive.execution.engine equal to MR, because I want to run as MapReduce. And now I want to paste that query. I'm sorry, it is off of clipboard. Let me copy it from here. So the same query might run here, but it complained when I say to use the positional notation, because it is, I think it is expecting a alias to this column name, to the expression column, which is sum of. So let me do this. Copy here order item subtotal, that is alias, and now let me copy paste this one. What is happening here? Okay, order item subtotal. Yeah, now it is running as a MapReduce application. So there will be some subtle differences between traditional RDBMSs and Hive. In this case, it is working without many issues, because it's a very simple query using joins. There is no not much user defined functions that are being used. When you try to use user defined functions or some fancy stuff like exists, not exists, in, and then you will actually see the tremendous difference between traditional RDBMSs and Hive based databases. So now the query is running in MapReduce. It took 51 seconds to run, and you can see it has retrieved 2176 records, and it is now sorted in descending order by fan shop, apparel, footwear, golf, by the order item subtotal amount. So fan shop is the top performing department for date 2014 July 24th. Similarly, you can go through other dates, and most of the dates is the same case. Fan shop is the best performing department within this organization. That being said, so whenever you want to run this report, it will take around 51 seconds, even when there is not much data set for the ETL purpose. So what we need to do is, instead of doing this, we should actually avoid joins whenever we want to process the data. For that reason, process the data for our reporting requirement, and for that reason we have to load this data into a denormalized table. And when you actually design your denormalized table, you need to do some homework on granularity and other data warehousing concepts you need to keep in mind. And already we have done that data modeling. We have created order underscore fact table under retail underscore EDW, and if you see, there is a table called order fact, and if you describe the table have all the fields from order items, and also it has product category department, and also it is partitioned by department. So in this case, as the data is partitioned by department, within the department, if you want to see the trends, it will be pretty efficient. But as I have mentioned to you earlier, when it comes to designing your physical tables for your facts and other reporting tables, you need to keep redundancy in mind, because there is a lack of support for indexes in Hive. They are not as sophisticated as in retail relational databases. So if you want to use the same data set to visualize in two different dimensions, one for product category department and other for order date to week to month to year, then probably you might have to clone the data into two copies, one partitioned by product category department and other partitioned by order date, and then you have to develop your ETL process to load both the tables. So now we have to insert into this table. For that, we will need to run insert overwrite table order fact, partition key is product category department, and here I am not doing any aggregation. I am just trying to join the data and store as is, so that we don't need to join later when we actually try to see the trends at different granularity from the same fact table. Okay, so insert override table order fact partition product category department, and now we have to query all the fields like order item order ID, order item order date, and order item product ID, order item quantity, and then order item subtotal, and order item product price. And then I need to get department name from departments table. So department name will be product category department in our fact table. There is no need to join orders for this query, because already that is taken care as part of our ODS table. ODS table already have order items in ODS, already have the field order item, order date, and we have populated using orders as part of while inserting data into order items in ODS earlier. So there is no need to join orders table in this case. So from order items, join products, OI join products, P on OI dot order item product ID equal to p dot product id, join categories, C on p dot product category id equal to c dot category id, join departments, d on c dot category department id equal to d dot department id, and hit enter. Okay, I have to prefix with schema names here. So insert, select, so it is retail underscore ODS dot and retail underscore ODS dot and then categories, retail underscore ODS dot, and the last one departments, retail underscore ODS dot. So now it is submitted as MapReduce job. It will join all these tables and load into our final table, which is partitioned by department in and the table name is order fact. And once this is run, we will review the results. So now the table is populated. It took 28 seconds because we didn't do the aggregation, and you can see that already there are 6 partitions, and each partition have the key associated with it already. And now if I want to get the top performing department on daily basis, I just have to understand order fact table and say select product category department, comma order date, comma sum of order item subtotal from order fact group by product category department, comma order date, order by order date, comma DSC. Here I have to give the alias order item subtotal and then from and then order by. So there is something wrong here. It should be order item order date. Sorry. Order item order date, because the order date field is represented as order item order date in order fact table. Come on. Okay, it's in the group by clause also. So when we ran the query earlier, it took 51.27 seconds, and now it took 43.118 seconds. All this time it took is for aggregation. The reason you don't see much difference is that we are dealing with a smaller data set. That's why you are not seeing much difference. But if you want to further fine tune it in the insert statement itself, you can actually do the aggregation also. In our case, we haven't done the aggregation in the insert statement, and we tend to store the data as is from order items in our order fact table, so that we can actually use the same table for different reports. Now data is partitioned on product category department, and you have the raw data covering all the order items in the table, which is the largest of all the four. And if you want to further fine tune it, we can create tables at lower granularity, and fine tune the performance. For example, instead of storing data as is on daily basis, we can aggregate by date, remove the order item order ID and order item product ID, and keep quantity subtotal, which are measures, along with product category department in our report table, and load into that, and then you can query that, and the performance will be much better. We will do that exercise as part of the next video. We will try to create report tables on top of this order, on top of this fact table, not from the source tables, and see whether our whether the performance of our requirement of getting getting the performance of the departments on daily basis will be faster if we remodel this fact table at a different granular level and run the reports against it. That being said, I hope you are enjoying the contents of on my channel. If you like this video, please click on the like button, and if you want to provide feedback or ask any technical questions, please use the comment section of the video. And if you have not subscribed to my channel yet, please do so. You will see a lot more content than just big data and Hadoop over time. Thank you. Bye.